Okay. So, like I was saying before, we are just having formula after formula after formula. And usually that's a real, like, there's not much to be gained. Well, yeah, in this case, with all of these all the ones we did yesterday and today, except for those two that I talked about, memorizing them is not going to really, and especially the ones we do today, I completely forgot about. Like, I mean, I forgot that this was a thing, and I was like, oh, that's right, this. So, again, there's like, but sometimes you'll use them, but usually you'll have some kind of reference material where you will reference this stuff if you need it. But you still need to see it at some point, and it's good to derive it. So that's what we're going to do. We're going to derive. There's 4 of them today. And again, they are going to come straight from these guys. So our old friends, sine x plus y, which is what?
Sine of x. Cosine of y.
Cosine y.
Plus.
Because sine is the same. Plus.
Cosine of x. Sine of y.
That's just how I like to do it, and you could do it either way. Oh, it's fine. Whatever you want to do. Cosine x. Okay? That's how I like to do it. Now let's do this one right below it. Sine x minus y. So what's that?
Cosine. Just the same thing but a minus. Right? Wait. Yeah, the same thing but a minus. Oh, sine of x.
Yeah. You're like, I know what you're doing. You don't know what I'm doing. You don't know where I'm going with this. So okay, so it goes. So sine goes sine cos sine cos. What is the SIG in between them?
Minus.
And then we still have x y and y x. Okay. Now watch what happens when I do this. I'm going to take these guys and add them together. These are just 2 equations. I could add 2 equations. Something's going to cancel. Let's look at the left-hand side. We're going to end up with sine x plus y plus sine x minus y. Now, you just said something's going to cancel. And look at that. This and this, when you add those together, Noah's not looking. Better look. That's fine. You're working. That's cool. These 2 are going to cancel out because you have the plus sine cosine. This is the exact same thing. The only thing is a minus. When you add them together, it's gone. So now we have this plus this, but that's the same thing. So we could just write that as 2 times this amount. Sine x cosine y. Now, the way it's presented in your book is they take then another step and they divide both sides of this by 2. So when you see this in your book, there's going to be brackets right here.
Oh, I did see that.
And they go 1/2, which is true. That is one way you could think about this. Okay, so you just divide both sides by 2. You get a half of that. Or in other words, it's kind of like an average of these things, if you think about it. You average those together and you get this. Right? Because how do you get an average? You take the 2 things, you take the number of things, add them up, and then divide by the number of things that you have. You have 2 things, you've added them, then you divide by that number. It's kind of like an average of these things. Gives you that. That's one way of thinking about it. For our purposes right now, because we're going to derive more stuff, I'm going to keep this 2 up here for right now. But that's how it is in your book. It'll say sine x cosine y is this stuff right there. That's how it's presented in your book. But what happens if instead of adding, I subtracted? Well, on the left-hand side, instead of this plus this, it would be this minus this. So we'd have sine x plus y minus sine x minus y. Then what happens over here? What cancels and then what?
The first one cancels.
Yeah, because you're taking this value, whatever it is, it could come out to be the square root of 2 or something. It's not going to be the square root of 2. It could come, well, it could be. Interesting. No, So this thing right here, you take it and you subtract the exact same thing it's gone. You take this and subtract that, and what do you get?
The same, 2 sine cosine.
2 of them, right? Because you have, sine y cosine x minus negative sine y cosine x. Minus minus is like a plus, and so you end up now with 2 sine y's cosine x's right there. And again, your book presents this where the 2's been divided out, and it has a 1/2 out here in front. Okay. Okay, so those are 2 identities. And this is called, is either the sum to product or product to sum. As you notice, there's a product, right? You take this and multiply it by that. You could change that over into a sum. And yes, this is a sum. You might say that's a difference. It's like, yeah, but it's plus a negative, right? So it's the same thing, right? Okay, everybody got that? Everybody see how we got that? Okay, so we did it with sine. Guess what we're going to do next? We're going to do it with cosine. Okay, so I'm going to get rid of these. We're going to do the same trick. We're just going to take the 2 things. We're going to start with cosine x plus y. So let's do it that way. I want to, yeah, why not? And then cosine x minus y. And what's cosine x plus y?
Cosine
of x, cosine of y minus sine of.
Is it? Then you said it's what? Minus
Sine of
sine
x.
Sine y. Now then, this one is going to be cosine x, cosine y plus because it's opposite. And so sine x sine y. Cool. Okay, so we're going to do the same trick. When we add them together, something cancels out. So we are going to get cosine x plus y plus cosine x minus y gives us what? Just adding those 2 equations together.
Oh, to the... Wait, the cosine... Nothing cancels. So it's... Cosine would be cosine of x plus y plus 2 cosine of x minus y. Wait.
Whoa. We've done the left-hand side. We take this and that, we add those together, and we got that. Now we're on the right-hand side. So when I add that equation to that equation, what happens?
It's 2 cosine x cosine y.
Right. Those 2 come together. These guys cancel. And so now we have 2 cosine x cosine y. Everybody buy that? Yeah. Right? Okay. Okay. So finally, how did I do this? Did I do it that way? I did do it that way. So we could take this one and subtract that. I don't want to do that because you can see what's going to happen. These guys are going to cancel. But then I'll have a negative and I'll have a minus and then I'll have a negative down here. I think that's how your book does it. Oh, and by the way, I didn't say it. I said it with the other 2. Your book does not have it with the 2 there. It brings the 2 over and has 1/2 this equals cosine x cosine y. It's the same thing. It's the same. If you have that one in your head, you get the other one for free, right? So the way I'm going to do this is it's just like, if I have x equals, let's say 5 minus y, and x, I don't know, y equals, how about 5 plus z. Now I could go ahead and say, well, hold up, I need to subtract these to get rid of the 5. And if I do that, like let's say I'm trying to eliminate the 5 and get this in terms of just y's and z's, like I could do this so that I say, well then x minus y will get rid of the 5's. But then I'd have a minus z minus a z for a minus 2z. And then you could take that and just multiply everybody through by a negative. You 2z. And then that would be a minus x plus y. Or in other words, y minus x equals 2z. Or you could just say, well, I'm going to take the positive thing and subtract off the negative thing to get to that point in the first place.
Oh, yeah.
So that's what I'm doing here. I'm going to say, since that guy is negative, I'm going to take this positive one and subtract off the negative one just to make everybody positive. So I'm doing this in opposite order, and it kind of breaks the nice symmetry here that we have x plus y, x minus y, x plus y, x minus y, x plus y, x minus y. Now I'm going to mess everything up and throw a wrench in everybody's day. I'm sorry, but this is how I want to do it. I'm going to do it that way. That way we don't end up with a negative over here. So there's a nice symmetry on this side, but we're forfeiting some symmetry over there. Whatever. This is how I like to do it. You can do it however you want. But that's what I'm going to do. So we're going to take the bottom one and subtract off the top one. When we do that, we take this number, whatever it happens to be, and subtract that very number off. So it's gone. Now I have this number. Subtract off the negative. Is adding a positive, so we have 2 sine x sine y. And to be clear, your book has this with the half on that side instead of a 2 right there. Doesn't matter. But for what we're about to, for the next 4 that we're about to derive, we're going to want that 2 there. Actually, it wouldn't matter either way. It's just, this is how your book presents the other one. And since it's already on the board, why make our lives any harder? So this is the thing. If you notice, like, okay, these would be useful if you happen to have maybe an equation that has something like this, like a sine 2x minus, say, a y, and then maybe plus sine 2x plus y. Then you'd say, oh, hey, look, that is that. And so it would be 2 sine 2x cosine y, right?
Yeah.
Cool. But what if you have something like this? What if you're working on something and you need to change this? And it says maybe you have a sine A plus a sine B. And you're like, I need to do something with this and I need to turn this into something, but I mean, there's some way. I mean, we know if you x plus y is not the same thing as x minus y, unless like y is 0 or something like that. There's very few. Let's just find it. I'm curious. X plus y equals x minus y. That's only going to happen whenever y is equal to negative y, or when 2y is equal to 0. So that's only going to work when y is equal to 0, in which case it's like it's not there in the first place, so you wouldn't be doing that, right? So there's a very limited number of cases where that's... So the idea then is what I'm saying is you're not always going to have this here. It would be nice if you had some 2 completely unrelated numbers, and maybe you could turn those into that. But the question is, well, we don't have that. How could we do that?
Well, you could do like sine of 1/2 a plus 1/2 a.
You're way ahead of me here. So the reasoning goes like this. It's like, well, let's say I had something like that. Like, instead of having sine something plus something, and then a sine something minus that thing, if instead it were any 2 numbers, say a and b, maybe it's like 3 theta and 2 theta plus 5 or something like that, right? How could we then do this? Well, we could kind of force this and say, well, or if it were, say, cosine and cosine, right? Or if it were a minus or a plus, whatever. The idea is, why don't we just write this a, as my x plus y? And why don't I just write this b as my x minus y?
Yeah.
And then we could get these in terms of a and b. There's a few ways we could do this. We could say, well, hold up. X plus y equals a. X minus y equals b. If you'd like, you could turn that into a matrix.
Yeah.
Or we could say, well, hold up. What can I do to these two equations to eliminate one of those variables? Is Adam, right? So I add these together, and what do I get on the left-hand side?
2x equals a plus b.
Equals a plus b. It's 2x equals a plus b. And now I get my x by itself.
A plus b over 2.
A plus b over 2 equals x. So now what can I do to get the y? And there's a few ways we could go.
You could substitute.
We could substitute. I don't want to do that. I think that's going to actually be harder. Why don't we do this trick that we did with this last one? Yeah, we could minus off one of them. If we take this one and minus that one off. We take this, minus that. The x's are gone. I have y minus a minus y. That's 2y. Over here I have a minus b. Divide through, and we get y is a minus b over 2. And so now, really, all we need to do is just plug this and that into each one of these. It'd be really easy over here. I'm going to do that real quick over here. And, yeah, because this will give us our next 4. So I'm going to go ahead and just knock out the right-hand side. So from the x and the y, we have 2 sine x, but now x we said is a plus b over 2. Cosine y is a minus b over 2. This is 2 sine a minus b over 2 cosine a plus b over 2. This is 2 cosine a plus b over 2 cosine a minus b over 2. Finally, 2 sine a plus b over 2 sine a minus b over 2. Now, left-hand side's super easy because how did we start with all this? X plus y is simply a, right? That's why we did this in the first place. But I just want to double check here. Is this indeed the case? Is it the case that x plus y is equal to that plus that? Let's just see. Is x plus y, we're asking, is that equal to a plus b over 2 plus a minus b over 2? Well, it's all over 2, so we have a plus b plus a minus b all over 2. Right? Right? Common denominator. The b's are gone, and I have 2 a's over 2.
And the 2 is gone.
2's are gone, and we're just left with an a. That's nice.
Yeah.
Let's try the x minus y. That changes that to a minus. Uh-oh. And so, minus that stuff. Everybody catch that? Right? Just double check me on that. Did I do that right? X minus y. X is that. Yes. Minus. Yes. Y is that. Yes. I subtract that. So now I have a plus b minus a minus minus is plus b all over 2. The a's are gone. I got 2 b's. Over 2 is gone. It's just b. So yeah, but we knew that because that's something we started there. But it's nice that we checked because what if I made a mistake somewhere? And then I just derived all this stuff that doesn't really work. It's nice to just check that, yes, indeed, when you make these substitutions here, it is the case that when you take your x minus y, you do end up with just a b. So, on the left-hand side, we have sine a plus sine b. Sine a minus sine b. Cosine A plus cosine B. Finally, cosine B minus cosine A. Again, your book does it in the order A, B. So it goes cosine A minus cosine B, but then it puts the negative on this side, which I just don't like.
It's not going to be A. The bottom. It's cosine B minus cosine A.
Thank you. I was looking over here. I was like, no, those are sines.
Yeah.
Okay, gotcha. Thank you. Yes. A. Okay. Let's double check that. X plus Y is A. X plus Y is A. Yes. Okay. Okay, and so these are the ones for this. These are called sum to product and product to sum formulas. I think this one's sum to product. And I think this one's product to sum. Because you have your thing, whatever it happens to be. There's your X, there's your Y. So there's your product, and you're turning it into a sum. And all that stuff. Blah, 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 blah. Who cares? Like I said, I've never seen these again. But, I mean, I say that, but I'm sure I have. I'm sure it's come up like once or twice. And again, you just look it up, right? These aren't ones that are absolutely essential that you remember. These are essential that you remember. And then, real quick, what were the ones we talked about last time?
It was 1/2 plus 1/2 of
1/2 plus 1/2 of what?
cosine of
It's equal to something.
x, right? Wait. Oh, of 2x.
2x gives you what?
Just cosine of x? No. Wait. It was
Cosine
just x.
squared.
Oh, cosine squared
X. Because that's what happens with the 2. You can think about it this way. You decrease the power on cosine, but you have to increase this guy by a factor of 2. And then this one, sine squared x is
1/2 plus 1/2 sine. No, cosine. Wait, no, sine. Oh, it is cosine.
it's a minus.
Oh, it's a minus.
Mm-hmm.
Oh.
You want to commit these to memory.
Yeah.
You really, really want to commit these to memory. These are good. Of course, your book does it this way. It has it written like this.
Yeah.
Which they're equivalent, right? And there are cases where you'll want to write it like this, but this is super useful for other stuff. So that's how I have it in my head. It's just like that. And yeah, so, okay. All right, any questions? Okay, your first 2 questions, I think I gave you 5 and 13. Yep, 5 and 13 for this homework. They're really, it's just like, they give you something like this and tell you to write it like that. It's super simple. Then they give you something like this and tell you to write it like that. It's that's why you're not doing all of them. They're really, it's just plug and play. Then of course we're gonna verify identities. So let's do some of that. All right. Can I erase all this stuff?
Yeah. I feel like when it gets colder.
It's cold. Yeah, it's the lack of heat. It's like this stuff freezes to the board. May not look like it, but I'm really working on it. So I'm putting a lot of elbow grease into this. That board is cold. It's like hurting my hand to touch it. All right. Okay. So I wanted to do this one. Ugh. Yeah, and I want you to see how they write this, because this is just terrible. We're verifying. This is from this section, number 20. This is verify the identity, and it's sine u minus sine v over cosine u minus cosine v equals negative cotan. And this is how it's written in your book. This is why I want to talk about this, because boy, this is annoying. 1/2 u minus v. What they mean by this is that this is cotan of these things.
Oh.
Yeah, I know. I hate when they do that. If they just consistently, but nobody does. Nobody does consistently put. It's always just written like that. That's what they mean. The only time that they will put that is if they meant cotan 1/2 u minus v, then they would put parentheses around this. But whenever you see something without parentheses and a bunch of gobbledygook, you assume that all that gobbledygook goes into the function. Because otherwise they would put parentheses there. So, sorry. Okay, so looking at this, I'm thinking, well, again, starting from the very top, whenever we want to verify an identity, usually I like to start with a more complicated side. Now, it looks like the left-hand side is more complicated, but even more to the point, you know that these are things you just got formulas for, right? And so we're in the section that's talking about this stuff here. I wonder what to do with it. Well, this is the thing. It's kind of why I wish we weren't doing a take-home quiz. Is because like on your take-home quiz, I'm just going to tell you do these problems from the book, and it'll be in the section that's on the thing, and so you'll know which ones to use. It's much harder when you're given a problem and you're not sure which one to use. Yeah, so let's think about this.
Yeah.
You know what I'm saying? Like, looking at this, you might think, oh, this is like, this might be one of those, whatever there's like a bunch of different choices you have.
I
would
probably just change the cotangent to sines and cosines first.
I probably would too. In fact, let's do that.
Oh.
Let's just so it's nice to just have some stuff out there, right? Like maybe we'll start there. We'll make this like a negative, and cotangent is whatever what.
Cosine of this.
Cosine stuff over sine stuff. So that's just u minus v over 2, isn't it? Yeah. And that's just u minus v over 2. Oops. And that's just that. Right? Like, or is it? Right? So let's see. I'm gonna look here.
Oh.
Look back at my thing, because we don't have them on the board anymore. We had sine, cosine. So, okay, I'm looking. So, this is how I would go about doing this. I may or may not do this first. I mean, just it's nice to have on the board so we can see where we're going. But I know that we're in the section that deals with these things. So I'm going to say, okay, what's sine u minus sine v? And I look here, it says that sine A minus sine B is, and so I'm just going to go from this side of the equation and say, okay, sine U minus sine V, it says it's the same thing as 2 cosine the thing plus the thing. So 2 cosine stuff, sine, it's a minus, yeah, so sine stuff. And mine says A's and B's, but those are U's and V's. Uh-oh, what do I do? Can I just... Wait, I'll just replace it with A's and B's, or U's and V's. So that would be U plus V, U minus V.
Oh, wait.
I mean... that's not that. Over 2. Okay. This is sine U minus V. Cosine sine, yes. U minus V. Okay, the bottom. Cosine U cosine V. So I have a cosine A cosine B.
Oh.
And so I'm going to say, okay. It's the same thing. Now, if you're coming off the book, this is not how we did it in class. You'll notice they do it with the A and the B, and then they have the negative here. You see? This is what I was saying. We did it with the B on the left-hand side.
Yeah.
They have the negative there. I'll show you this. We did it with the cosine B on the left side. And we had cosine B minus cosine A. They have it with the negative. But since I'm using the book, I'm literally just saying, okay, I'm going to replace the U's with A's. So I'm going to do it the way that the book says. And I'm going to say, okay, well then that's negative 2 sine.
Oh, and the signs cancel.
And then, yeah, and so now we have, it's A plus B. And I'm checking here that I'm in the right order. Because if it's B minus A, it's going to be different with these, right?
Yeah.
So it has the A here and the B here in the formula I'm looking for. So that needs to be A. So my A's become U's, my V's become B's. So we have A plus B. Okay, U plus V over 2, and then U minus V over 2. If you're absolutely stuck, what probably happened is that one of these was in the wrong order as you were doing it. Because you notice I just had a problem with it too. I'm like, wait, there's the A and there's the B and there's the this. It could be that you're like, okay, the U's and the V's are this. But if this were a V and a U, you might just look at the thing and go, okay, the A comes before the B. So that it's going to be A minus B. But if that's switched, you have to take that into account. Okay, so now I see what's happening. A bunch of stuff cancels, actually.
The 2's.
The 2's cancel.
And the sine of U minus V.
And the minus ones cancel with the signs. And so I have just a... And there's a negative down there, so he's going to come along for the ride. Right, I'm just going to throw him out front. And I'm left with cosine U plus V over 2. On the top, on the bottom, I have sine U plus V over 2.
But there's a minus. Oh, but cosine of...
This was a minus.
Yeah, but we're trying to turn it into at the very top.
Ah!
No, you didn't make... It's fine, but there's a minus... We're supposed to turn it into cosine of U minus V over 2.
Ah!
Oh, but cosine... we can just put a negative in it.
You can put it in, because...
Oh, wait, no, that doesn't work.
Isn't negative cosine of...
What did we do wrong?
What happened? I swear I did this earlier. Oh, I'll tell you what happened. It's supposed to be a plus. That's why. It is supposed to be a plus. Okay. That could have been really bad. Yeah, but that's okay. So, I know I did that one earlier. I was like, wait, what's going on? Yeah, just copied it wrong. That's another thing. If you get to this point and you're like, wait a minute, but I can't put it, I can put a negative in here, but then that makes it negative U, negative V. Yeah, and so maybe you just copied the problem wrong in the beginning. And so yes, this is the same thing as negative cotan U plus V over 2, which is indeed what they gave me at the very original. Cotan 1/2 U plus V. Done. All right. This is... let's do another one like that. Okay. Good?
Yeah.
Good. I'll try to copy this next one correctly. Accurately sounds better than correctly. Precisely. I like that. This is number 24 from that section. Come on, you. Alright. This is really ugly. Okay. Cosine T plus cosine 4T plus cosine 7T. Yeah. Sine T over sine T plus sine 4t plus sine, can you guess?
7t?
7t.
Okay.
Okay, yeah. Because if it wasn't, like, my intuition tells me we would be in for a really rough ride. That's equal to cotan 4t. Okay, so again, it may or may not help us to go ahead and just say, well, wait a second. Oh, we've got sines and cosines on the left-hand side. Maybe if we start off with sines and cosines on the right-hand side, maybe that'll help us. Because then we'll also know when to stop, right? Because like if we had left the original, the first one that we did as like negative cotan 1/2 u plus v, and then as we kept going, we might not recognize like, oh, we got there. That's it. That's what we're looking for. So maybe this will help. Maybe not. It's what over what?
Cosine over
4t over sine.
Yeah.
4t.
Cosine 4t on the top, sine 4t on the bottom.
Wait, so if this is true, then the sine of 7, like, everything just goes away except for the...
Oh.
Hmm.
Oh yeah.
Hmm.
Weird.
Should. So maybe, and this is one of those nice things about that, is maybe that gives us a way of going about doing this. Maybe, I don't know, but maybe that's kind of the idea, is if I could get these guys, maybe I should try to bring these guys together and just see.
And then try to make them...
Maybe. I don't know, but let's just try it. So I'm groping it. I'm going to pretend I haven't done this one. And I'm going to just grope in the dark here and see what happens. So what I'm going to do, the way I'm going to organize this, is I'm going to leave these guys over to the left, bring these guys over, and kind of do this type of thing and say, okay, how about this? The part that I want to leave alone, I'll just leave on the left-hand side, or further to the left. And hopefully, all of this stuff just kind of works out to cosine t plus cosine 7t. This should be sine t plus sine 7t. And maybe we can get these guys to work. So, okay, cosine plus... Oh, right, I'm going to get my reference out here. Oh, we could... Now, it says that cosine plus cosine gives me 2 cosine cosine. So, okay, I'll do that. I'm going to copy this cosine 4t. Sine 4t. That, just copying out of here, cosine that plus, yes, cosine plus cosine is 2 cosine cosine now what it says to do is it's the average and then the difference. So 7t plus t over 2 and 7t minus t over 2.
So 8t over 2 and 6t over
8t over 2 and 6t over 2. Okay, now, give it a second. We'll get there in a second. Let's do the bottom one. Sine, it says 2 sine cosine. So I'm going to go 2 sine cosine. Now I want to make sure I don't mess these up because it's not the same. Like, it wouldn't matter if you had done this one and this one and this one and that one, right? Because it's cosine, cosine. Now we have a sine and a cosine, so I have to be very careful of which ones I put in what. Okay? And this one says that the difference goes into cosine, and the sum goes into sine. So, the sine gets 7t plus t over 2. Cosine gets, and I have to also, well, actually, it shouldn't matter which way I do it. Because, right, the sine,
Yeah.
it goes into cosine, but if it's negative, negative cosine comes out as nothing.
Oh yeah.
Right?
Yeah.
Because cosine negative x is the same thing as cosine x.
Yeah. So
Because it's an even function. And so it actually doesn't matter in the cosine. But maybe in order to cancel things out, which is maybe something that's about to happen, maybe if and when I do that, well, I will talk about that in just a second. So I'm going to go ahead and say 7t minus t, just for a nice symmetry here. 7t minus t all over 2. Because again, it doesn't matter. When it's plus, it doesn't matter whether you did it that way or that way. When it's minus over here, it does matter. But when it's plus, it doesn't. So these are just some pitfalls you might fall into here. But things that you would definitely want to keep in mind. So now let's go ahead and simplify these guys. You said that's the same thing as 8t over 2. Which is how many t's? 4. Which is good, because look, there's this stuff here too. Like, this is kind of leading me to think like, yeah, this looks good. So I'm going to go ahead and take my 7t plus t over 2 and just rewrite it as 4t. Okay, just to save space, I'm going to erase this. 4t. Same thing down here, that's 8t over 2, which reduces down to 4t.
The others are 3t over 2.
The others are 6t over 2, which reduces down to... I need to see it. Yes, it does go down to 3t. Okay, so here's 3t and 3t. 3t, 3t. Now, what do we do? Well, where are we trying to get? We're trying to get so where there's just a cosine 4t and just a sine 4t.
I feel like we could split up the fraction and cancel the t. Wait, no, we can't. Yes.
Oh.
Yeah, we can.
We could. What do you?
Right now,
Can't.
No, you could.
never mind.
Yeah, because this entire thing would be in the denominator,
Yeah.
and so you'd have this thing. You'd have that over this plus that over this. And you have.
You can factor out.
What? Factor what out?
A cosine of 4t at the top.
Okay, so I could, yes, because we have a cosine 4t here and here. And so cosine 4t comes out, leaving me what in the parentheses?
1 plus 2 cosine of 3t.
Cosine 3.
Oh, I see. And
then
then those are going to cancel.
And then what do we do on the bottom?
Factor out
Sine of 4t.
Mm-hmm.
Giving us 1 plus
1 plus 2 cosine of 3t.
There we go.
And then those. Okay.
And then those cancel, and we are where we wanted to be. So that is the same thing as cotan 4t. Now, this is what I wanted to say just a minute ago, is especially like this works because you have t's and like 7t minus 1t is 6t, which is even, so you could divide it by and reduce it down, and that's easy to see. But if we had written this differently, it's very possible that here in the end we could have had something that looked like this. What was it? 7t plus t over 2. And if this were written differently, or if I looked there because of the fact that this is a sine and there's a plus here, it could have been written either way, because sine t plus sine 7t is the same thing as sine 7t plus sine t, right?
Yeah.
Like they go either way. Then my formula would have told me to do it this way. Instead of 7t minus t, it would have been t minus 7t.
Oh, and then there'd be, but actually it wouldn't matter.
It wouldn't, but here's the thing. You would get to this point that we just got to, and you could look at that and say, uh-oh, 7t plus t over 2 and t minus
7t.
That should have been a minus. That was also a minus. T minus 7t over 2 are the same thing, or not the same thing. Yes, they are. Because you could factor out a negative, right? You could say, wait a second, cosine t minus 7t over 2 is the same thing as cosine of negative 7t minus t over 2.
Negative cosine.
And negative, right? Like I just had it on the board. Cosine of negative x is equal to positive cosine of positive x. And so you'd say, that is equal to this thing. So that's something that might come up in the homework, where it looks like everything's almost there. It's like, but that's not the same thing as that. It could be that just in disguise. Okay, you've got to be careful with that, especially when you're just plugging stuff into formulas. We very easily could have just written it a different way, and then we would have ended up with something that looks like this. And if these weren't t's, by the way, like that happened to be a 7t and a t, and so we could just reduce it down and it came out to 3t in both cases. But it might have been the case that, instead of like a t, you have a t, 7t, and an h. And then you have 7t minus h, and h minus 7t, and you're like, well, those aren't even close to the same thing. Yeah, it turns out they are because of this. So you got to be really careful with that kind of stuff with these. Okay? Okay. Questions before we do one more example? Okay. This one. All right. Okay. Me.
Need like a hair dryer.
That would help. Or if this heater back here worked, which it doesn't. Okay, so 34. Find solutions to this equation. So, we happen to be in the part of the book that gives you a bunch of formulas for this. If you just had a quiz and this popped up, oh man, a bunch of stuff would be going through my head right now.
Yeah.
One thing to identify is that these all have different input values, right? One's a 1x, one of them's a 3x, one of them's a 5x. So that should kind of signal to you that this is something to do with the stuff we've been talking about both on Tuesday and today. Okay. Now, but given that and so I'm looking at that and I'm thinking, okay, this is probably something with product to sum, because we have different inputs here. And what did we do last time? They were the multiple angle formulas. I'm not seeing anything that's doubled, right? The multiple angle formulas all have to do with doubling things. And so maybe if I had like a 3x and then over here a 6x, I might think double. Or maybe if we had a 5x and a 10x, maybe, I don't know. But the fact that we have x, 3x, and 5x, well, two of those are prime numbers, and like, so this is signaling to me that maybe this is like a product of sum. And I have some here. So that's where I want to start. And I also know that in those formulas, you have a sum of sine and sine, or sine and cosine. No, I'm sorry. It's always sine and sine, or cosine and cosine. That's another thing. Because maybe, often, like one thing that I've been saying since last year is, if you have an equation, get it equal to 0. Usually that's something you want to do. Now we're starting to see that maybe not. Maybe not in this case. So what we're going to do then is say, because I notice, right, like I said before, that in all of the formulas we had with a sine plus or minus a sine, or a cosine plus or minus a cosine, it came out to equal 2 times something. Maybe that's going to help me. So that's my reasoning when I look at something like this out of context. When I look at this in context, I go, oh, we're in this section. I know what to do. The left-hand side, there's a formula for that left-hand side. And I don't want to mess this up. And like I said, these are ones that I have not committed to memory. So I'm going to use the book so that I don't mess this up. We have sine something minus sine something is 2. So I'm just going to start with the left-hand side. This is the same thing as 2. This says cosine sine. So cosine sine. Now I'm going to go ahead and copy this part down so I don't forget it and mess that up. Okay, so this should be this is the same thing as that. Now for this, the A is that and the B is that. So I'm going to get my A plus B over 2. So 5x plus x over 2. And then in my sine goes the difference. 5x minus x over 2. That's not so bad. So, this is the same thing as 2 cosine what?
3x.
3x. This is sine
2x.
right, because 4x over 2 is 2x.
Oh, and those. Wait.
Yeah.
Our 2's are 2 cosine 3x. Divide by
Well,
Wait,
then-
no,
and
that would
here's
lose
the
it.
thing, right? Well, the 2's are gone. We can forget the 2's.
Oh.
But here's the thing. You
You
could say,
can't-
oh, divide through by 3x, but then you're going to forget about all of those places where it's equal to 0.
So you have to minus it and factor.
Minus it out, right? This is what you should whenever
Yeah.
you're dealing with sines and cosine or any trig anything, get in the habit of just getting that side equal to 0. So like just a second ago I said that's not going to help us. Well, I mean,
Eventually.
you still want to do it. You absolutely want to do it. Get that thing equal to 0. And I guess we could have done that as the first step, but then you're looking at a bunch of sines and cosines all together and it's kind of hard to see. And so now in this case, this is what I'm going to do. I'm going to factor that guy out. Cosine 3x. 0. And now what's left is the sine.
2x minus 1. And now we have 2 equations.
2 equations. On one hand, we have cosine 3x is equal to 0. And we have sine 2x is equal to 1. And so if this were a sine theta equals 1, I would say that that happens at pi over 2 plus, and I can see this is my whole period, so it's going to be plus 2 pi.
So we're finding all this, not just the ones.
Yeah. So this would be that theta is pi over 2 plus 2 pi n. But we don't care about theta, we care about 2x. So 2x, pi over 2 plus 2 pi n. Divide through, and we get pi over 4 plus pi n as 1. Cosine, if cosine theta is equal to 0, we could see that that happens, in 2 places. We have here, where's here and where's here?
Pi over 2 and 3 pi over 2.
So that's off by pi. And if we go off by pi, we'll just be banana. We'll just do it the safe way. The safe way is to just say, okay, well that's when theta is equal to pi over 2 plus 2 pi n. Or when theta is equal to 3 pi over 2 plus 2 pi n. Right? Because that's one full period and so it repeats and everything. You could probably just do it by saying that plus pi. But like I said, I'm being safe because I'm trying to just get this done and I don't want to have to stop and go, wait. Just doing it. So we don't care about theta, we care about 3x. Or 3x equal to 3 pi over 2 plus 2 pi n. And so then I divide through by 3, and I get pi over 6 plus 2 pi over 3n. or x is equal to the 3's cancel, and I get my pi over 2 plus 2 pi over 3. And I think these are... Or are they? You see, I don't even have to think about it. I don't have to think about it now.
Yeah.
Maybe I gave my teacher one too many things. Whatever. So, like...
They're equivalent then.
They're right. And so, yes, if you were really dead set on simplifying these guys, you could go through and see, are these equivalent? You know, like, were we just off by pi to begin with? Did we write more than we needed to write? Or you could just say, hey, I'm confident this works. And it does. How much time do we have? Because if I would like to go over, you said you wanted to do 41 from the last one? Oh, we're way over. But we started way late, so let's just do it. You said it was 41, right, Victor?
Yeah, that's the last one.
The last one, okay. 41. It says find solutions that are in the interval 0 up to 2 pi. So we're solving on 0 to 2 pi, and it is sine of 1/2 u. So that's not 1 over 2u. Maybe that's what messed you up.
Wait, what?
It's not 1 over 2u. It's 1/2 u.
Are you sure?
I'm looking at it.
My book is...
No.
What? Okay, well, I figured out the trouble.
Yeah, okay. Yeah, I know. Yeah. They do that. They do. I know. And it does kind of look like 1 over 2u, but that's just 1/2 u.
So you were,
Yeah. So there's that. That should take care of it for you. Right? There's the problem. Like, I don't know what to do with over, because that would be some very difficult stuff.
Yeah.
So yeah, that's the problem. So that's u over 2, which you could then use let's just do it real quick. So we know that sine u over 2, which is, that's what that is, well, sine squared is 1/2 minus 1/2 cosine u, right? Bring that down by half, you do that. Right, or multiply that guy by 2 to bring that thing down by half. So we could say then sine of u over 2 is then the square root of that stuff.
Oh, that's not how I did it. I got them both to sine 1/2 u.
Oh!
Because I thought that was easy.
It probably is. Yeah, because what we're about to do, then we'd have to square that out. I like that. Good thinking. So, you got that one to, so watch that. Yeah. Cosine u should be the same thing as sine squared
Yeah. Wait, cosine?
u over 2.
Yeah, u.
Like that. Yes? Did I do that right? Yeah, yeah. I double the input. Bring the power down. Oops.
Oh my.
Minus. There you go. And so since that's the case, and there's the formula, this is how I did it, right? But the formula would be this. That. So then this is this cosine u 1 minus 2 sine squared u over 2. Just like that. And we pop that guy in there. So now we have sine u over 2 plus all that stuff, which is 1 minus 2 sine squared u over 2. Is that how you did it?
Yes.
Okay. And so the ones cancel. since the ones cancel, I'm going to go ahead and bring him over here to give me a sine u over 2. Oh, no, I'm not going to do that. Those guys are gone. Pull out a sine u over 2, leaving me a 1 minus 2 sine u over 2 equals 0.
And then you have
And then, yes, and then we have two equations that sine u over 2 is equal to 0, or that would come over and we would have sine u over 2 is just positive 1/2.
Yeah.
Okay. And then from there, that stuff we've done 100 times. So, cool?
Yeah.
So it was just, it looked like 1 over 2u, and yeah.